Guys, welcome back. Really, I've noticed that the last video actually had more views than the previous videos. So be careful, guys. Try not to watch these out of sequence because it's kind of important. There's a reason why they're in this kind of sequence, and it's important for you to watch the previous videos before you go to this one. So we're kind of continuing that conversation of doing proofs. So on the last video, I told you guys that when you're doing proofs, you cannot treat the original question like an equation because the whole idea here is you're trying to prove this is an equation. So we're only allowed to work on one side of the equation, and anytime you're using Pythagorean identity, you need to make sure you do show that in the communication. So in this case, you actually have two options. Now, in the previous two questions, I've always worked on the left-hand side. So I want to show you guys, it actually doesn't matter which side you work at. So this time, I'm going to pick the right-hand side. So I'm going to keep the left-hand side the same. Now, I'm going to rewrite these in terms of sine and cosine because sometimes when I don't see what I'm doing, it is very important and it's probably very helpful for you to go back to the basics. So secant x is 1 over cosine x minus cosine x. So I'm taking a look at the structure. This is a monomial. This is a binomial. So in order to take this side to this side, it does look like I need to combine these fractions over again. So this is kind of like cosine x over 1. So in order to add two fractions together, or a fraction with a whole number, I do need to have a common denominator. So it looks like I'm going to have to multiply this one by a cosine x over a cosine x, so which is going to give me 1 minus cosine squared x over cosine x. Again, I'm jumping a little bit on the arithmetics because technically that's not very hard for you guys to see how I go from here to here. But if not, then I would suggest when you're writing the notes to really build in those steps for you. So again, we multiply the top and the bottom, the numerator denominator of this fraction by cosine x. So that gives me cosine squared x over cosine x. And when the denominator is the same, I can add the numerator, which is 1 minus cosine squared x. Now, this is again a monomial, this is a binomial, which means I'm actually using a Pythagorean identity here. And what Pythagorean identity do we know that has to do with cosine squared x? It's the first one. And yes, you have to write this out every single time. Okay? Please do not take shortcuts, people. So sine squared x is equal to 1 minus cosine squared x, which is what I need over here. So I have tangent x over cosecant x is equal to sine squared x over cosine x. Some of you guys are going, wait a minute, so how do we go from here to here? Well, I can split it. So tangent x over cosecant x is equal to sine x over cosine x, because I took one of the sine x in the numerator and distributed on top, times a sine x. And we all know that to be true. Now, what's sine x over cosine x? Well, that's tangent x. Okay? Now, if I were to write sine x as a fraction, because I do need a denominator here, I can rewrite this as 1 over cosecant x, because they're reciprocal functions of each other. Okay? Which will then take me to where I need to be, which is, I'm going to write it over here because I'm running a little bit out of the room. So tangent x over cosecant x is equal to tangent x over cosecant x, which then finishes my proof. Okay? So again, it really doesn't matter which side of the question you're going to start with. Just remember, you're only allowed to change one side, and you must communicate the Pythagorean identity that you're using. Okay? Okay, so that's example C. And again, you can always pause the video if you need to copy certain things down or think about certain things as we're going through it. Okay, to save time, I'm just going to move on to the next one. So here's the next question, and we're part D now. We're doing secant x over 1 plus cosine x, which is equal to cosecant x squared x times secant x minus 1. Now here's the thing, guys. A lot of times when you're doing proofs, you do understand. There's no, oh, I see what's happening right away. Like, I have a plan. I know how to do it step by step. A lot of times, you just literally have to try. And if it's not working, then you retrace your steps and figure out what happened. And if there's no error, that means this particular method might not work for you, then try something else. There's really no other way to do identity or proofs other than just really trying. So on this question, some of you guys might choose to change this to 1 over sine x and work from here. I actually have a different idea. I'm going to do something on this side. So I'm going to take secant x over 1 plus cosine x. I'm going to multiply this by the conjugate of this, 1 minus cosine x. And some of you guys might go, well, Mazay, what made you think you want to do that? Because I see a cosecant square x, which is 1 over sine squared x. And when I see this, the kind of pathway for me to get to sine squared x is if I can get the denominator to look like 1 minus cosine squared x, because that's a Pythagorean identity. And in order to get 1 minus cosine squared x, it makes sense for me to multiply by the conjugate. Okay? But again, this is not the only way for you to do this question. Some of you guys might choose to start on the right-hand side because there's more moving parts to that. It's up to you. So I'm going to get secant x times 1 minus cosine x over 1 minus cosine squared x, which is equal to cosecant squared x times secant x minus 1. Okay? If I distribute in the numerator, I'm actually going to get secant x minus, well, secant x times cosine x, they're reciprocal of each other. So when you multiply them, you're always going to get a 1. Okay? Over, and this is the part we have to communicate using the Pythagorean identity. So Pythagorean identity. And the one I'm using here, again, is sine squared x plus cosine squared x equals to 1, which means sine squared x is equal to 1 minus cosine squared x. Okay, so that means I can replace this with sine squared x, which is equal to cosecant squared x times secant x minus 1. Now for some of you guys who needs a little help in seeing this, I'm going to rewrite it just for you. Is that still valid? Of course, I can always rewrite this fraction as a fraction multiplied by the numerator. Okay? And 1 over sine squared x is actually cosecant squared x. So again, we proved our identity. Okay? All the communication's there, all the work's there, we've gone through it. Alright. Okay, now for those of you who want additional practice, I would say for this question, maybe on a separate sheet of paper, instead of my work, see if you can take from this side, go into this side. So try something else. Take it from cosecant squared x times secant x minus 1. See if you can get that into secant x over 1 plus cosine x. Okay? Alright. Last example. I'm going to leave the Pythagorean identity word there so I don't have to write it again next time. Okay? Alright. E. Okay. Again, it's up to you how you want to do this. I might choose to go ahead and take this binomial square and distribute it. So if I do that, I'm going to get secant squared theta minus 2 secant theta tangent theta plus tangent squared theta which is equal to 1 minus sine theta over 1 plus sine theta. Okay. So this is 1 over cosine squared theta minus 2 times 1 over cosine theta times sine theta over cosine theta, okay, plus sine squared theta over cosine squared theta. Now some of you guys might go, Ms. A, why are you writing everything out? Well, it's because when I look on the other side, there's only sine theta, so this might not be a bad way to approach it, where I take everything and change it back into sine and cosine. Now I started noticing, when I multiply this together, I'm going to get cosine squared theta here. And all the denominators now become cosine squared theta, which means all three of these could be combined into one fraction of 1 minus 2 sine theta plus sine squared theta over cosine squared theta. And if I take a look at this, what we're going to say to ourselves is, hello, old friend. Because if you say let u equals to sine theta, u squared equals to sine squared theta, this is now quadratic. It's the equivalent of 1 minus 2u plus u squared, which we know is factorable into 1 minus u squared. That means I can actually go ahead and factor the numerator into 1 minus sine theta squared. And you guys thought factoring was not useful. Now, I notice there's a 1 plus sine theta in the denominator here, but I have cosine squared theta, which means I need to use a Pythagorean identity. And again, by now, you guys should be automatically jumping to which one you're going to use. Now, it's not always going to be this one, but if you have your Pythagorean identities memorized, you should always know which one you're going to pick. Because of the 3 identities, basically the 6 trig ratios only show up once in each of them. So I have cosine squared theta is equal to 1 minus sine squared theta, which means I get to replace over here. Okay. And that's a difference of squares, which means I can factor it further. Again, guys, there's a reason why I told you to really know your factoring. Because have you not noticed we've been using the factoring method all the way through the whole entire year? And guess what? You're still going to be using that next year in Calculus D as well. So in this case, there's 1 minus sine theta in both the numerator and denominator, which then can cancel. So I'm going to get 1 minus sine theta over 1 plus sine theta, which is equal to 1 minus sine theta over 1 plus sine theta. Okay, which completes our proof. Like I said again, for some of you guys, you see things differently than me. You might choose to go from the right to the left. And that's fine too. And in fact, when I post the homework solution for the homework that I give you, the homework number 36, you're going to notice sometimes I did things differently than yours. And that's fine, guys. Like I said again, as long as your work is mathematically correct, okay, and you can justify your work mathematically, you identified your Pythagorean identity, I really don't care you're not doing the same way I do. Because sometimes there's like a million different ways to do this. And that's what makes proofs a lot of fun. My past Math 3 honor students have told me that proof is actually one of their favorite homework. Because they actually get to explore the different ways that they can do it. And since they already know what the answer is supposed to look like, it kind of helps guide their steps. So again, that finishes our 19.4, the whole entire PowerPoint. If you have any questions, feel free to ask me. I will start posting the homework number 36 solution this weekend. Okay, so for now, I'm going to sign off, and I hope you guys are healthy and safe, and, and I miss you until we see each other again. Bye, guys.